this video, we're going to cover circuit diagrams. Drawing realistic pictures of circuits can be very difficult. For this reason, we have common symbols to represent each piece. Here we have the symbol of resistor. Here is a battery. Here's a copper wire. You can see that this is the actual resistor, this is the actual battery, and here are the wires. It's kind of difficult to draw some of these things. Just a note, circuit diagrams do not show where each part is physically located. Okay, it just shows how they're connected to one another. So here we're going to draw a simple circuit that has a 9-volt battery with a 3-ohm resistor across its terminals. We want to know what is the magnitude and direction of the current. So go ahead and pause the video and see if you can do this one on your own. If it's been a while since you've done circuits, you might need to let the video play instead of pausing it. Okay, so let's take a look. First, we're going to draw our circuit. Now, it says here we have a 9-volt battery, so there's our battery, and we label it 9 volts. We have a 3-ohm resistor. There's our resistor. Notice how we connect with a square or a rectangle. Okay, we never make it a curved line when drawing schematics. We always draw the wires at right angles. Now, in order to find the current, what do we need to do? That's right, we need to use Ohm's law. So, writing it out, we have V equals IR. I is equal to V divided by R, which is equal to 9 volts divided by 3 ohms. And that gives us a current of 3 amps. Now, which way does it go? It comes out of the plus terminal and goes into the minus terminal. Remember, we're drawing our circuit due to conventional current. There are 2 ways to add a second resistor to the circuit. We can add it in series, which means that the same current flows through both resistors, or we can wire them in parallel, in which that electron has to choose which path it wants to take. All charges must move through both resistors to get to the negative terminal in a series circuit. Charges can pass through either R1 or R2, but not both when looking at a parallel circuit. Are the following sets of resistors in series or parallel? Look at the first one first. What do you think? If you selected that it was in parallel, you are correct. What about this circuit right here? If you said series, you are correct. Okay, how can you tell? Well, we draw the current lines. The current comes out of the plus terminal and goes into the minus terminal. Notice here, I have to choose which way I'm going to go. Am I going to go this way, or am I going to go this way? I can't go both. So what happens is I end up splitting my current, and that means that 2 different currents go through these resistors. And that means I am in parallel. Whereas here, from the plus terminal to the minus terminal, I have the current I, and it just keeps going and going until it gets to the negative terminal of the battery. Let's talk about equivalent resistance. Resistors and voltage from batteries determine the current. Circuits can be redrawn as if they were only a single resistor and battery. By reducing the circuit this way, the circuit becomes easier to study. The process of reducing the resistors in a circuit is called finding the equivalent resistance. So in other words, we would take this circuit of 2 resistors and reduce it down to 1. That 1 resistor would be called the equivalent resistor. What happens to the current in the circuit to the right? Let's see. The current will pass through all parts in a series circuit, so the current through R1 and R2 is going to be equal to I. What happens to the voltage as it moves across the circuit or around the circuit? That's a little bit trickier. The sum of the voltage drops across each resistor in a series circuit add up to give you the voltage of the battery. So this would be called V1, this would be called V2, I would be the current through both, and also through the battery. So in a series circuit, V is equal to V1 plus V2 plus V3. If we substitute in IR for V, we end up with IR equals I1R1 plus I2R2 plus I3R3. But we know that the current is the same, so all of these I's are the same. That means that they cancel out. And I'm left with the equivalent resistance is given as R1 plus R2 plus R3 and so on. So to find the equivalent resistance of a series circuit, you just add the resistance of all the resistors together. If you add more resistors to a series circuit, what's going to happen to the resistance? It's going to increase. So what is the equivalent resistance in this circuit? Go ahead and pause the video if you need to. Okay. If you add 5 ohms plus 3 ohms, you should end up with 8 ohms. What is the total current at any spot in the circuit? Now this is tricky. Okay, so let's see if you have the correct answer. First thing we use is the equivalent resistance of 8 ohms. We then use that 8 ohms to solve for the current. You cannot use the 5 ohm resistor or the 3 ohm resistor by itself, because that's not going to tell us the total current in the circuit. Okay? We would need to know what the voltage drop was for R1 and what the voltage drop for R2 is. Remember, it's not going to be 9 volts. 9 volts is the sum of V1 plus V2. Okay, so I is equal to the 9 volts divided by the 8 ohms, and that gives us 1.1 amps. What is the voltage drop across R1? Pause the video if you need to. Okay, so let's take a look. First thing we have to do is find the equivalent resistance, and that's 8 ohms. The next thing we need to do is find the total current in the circuit everywhere, and that's going to be the total voltage, 9 volts, divided by the total net resistance or equivalent resistance, which is 8 ohms. That gives us again the current of 1.1 amps. We know that 1.1 amps goes through both resistors. So now we know that V1 is equal to I1 times R1, and we can just multiply the two together, and we end up with 5.6 volts as our voltage drop on that 5 ohm resistor. What is the voltage drop now across R2? Okay, so let's take a look. We're not going to keep repeating everything. Okay, we know that the current is, from the previous problem, is 1.1 amps. So what you need to do is you need to take the 3 ohms times the 1.1 amps, and that gives us 3.4 volts. So a good way to check and make sure your work is correct is by taking the voltage drops and making sure they add up to give you 9. So in this one we have 3.4. Here we have 5.6. So if you add them together, do you get 9? A little bit, yes. Okay. How much power is used by R1? Now remember, power is equal to IV. Which I and which V should you use, though? Go ahead and pause the video. Okay, so let's take a look. Remember from the previous example, we found that the current was 1.1 amps. We know the voltage drop on R1 is 5.6 volts. If we take the current times the voltage, that gives us 6.3 watts. So you use V1 times I1, and it just so happens that I1 is the same as I. So what happens to the current in the circuit to the right? Now remember, this is not the same as the previous examples. Okay, so let's take a look and see if you're correct. Hopefully you said that the sum of the currents through each of the resistors in the parallel circuit will equal the total current of the battery. That would be correct. So in this case, I, the current of the battery, is equal to I1 plus I2. What happens to the voltage as it moves around the circuit? Go ahead and pause if you need to. Okay, so let's take a look. Hopefully you said that the voltage across all the resistors in a parallel circuit is the same. And that's because this piece here is touching the positive terminal, this is touching the negative terminal, and I could easily do that without even having these wires here. Okay, so that means that the potential difference from here to here has to be the same for both resistors because they're both in contact with the same point on the battery. So if we rewrite Ohm's law for I and substitute for each resistor, we get V over R equals V1 over R1 plus V2 over R2 plus V3 over R3. We know that the voltage drop is the same for all resistors in parallel, so we can substitute in V for V1, V2, and V3. We also can see that both sides of the equation have V, so we can actually factor the V out here and then divide by V. Okay, so just divide by V, and that ends up giving us 1 over the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on. Okay, if you add more resistors in parallel, what will happen to the resistance of the circuit then? Hopefully you said it will reduce the resistance. The more resistors you add in parallel, the lower the resistance gets. Okay, so what is the equivalent resistance of this circuit? Go ahead and pause the video. Okay, so let's take a look at your solution. Hopefully you said 1 over 3 plus 1 over 6 equals 1 over R equivalent. Here we're finding a common denominator, which is 6. And that gives us 3 over 6 is equal to 1 over R equivalent. If we take the inverse of both sides, R equivalent is equal to 2 ohms. What is the voltage at any spot in the circuit? Hopefully you don't need to pause the video. If you do, just pause now. Okay, so let's take a look. It should be 18 volts. You're in parallel, so the resistors are going to have the same voltage drop as the power supply. What is the current through R1? Okay, this is a little bit tricky. Okay, so let's take a look. I1 is equal to V1 over R1. Well, V1 is the power supply because you only have these 2 resistors and they're in parallel with the battery. So 18 divided by 3 gives you 6 amps. What's the current through R2? That's right, you're going to do the same thing. You're going to take 18, though, and divide it by 6, not 3, and that gives you 3 amps. What is the power used by R1? Go ahead and pause if you need to. Okay, so the power is equal to I1 V1. We saw for I in the previous part, it's 6 amps. So 6 times 18 gives us 108 watts. What is the power used by R2? You can use the current from the previous solution. Okay, so let's take a look. Power is equal to I2 R2. We take 3 times the 18 volts, and that gives us 54 watts. What is the total current in this circuit? Okay, this is a lot trickier, so go ahead and pause if you really want to look at how you would solve this or think about it, and I recommend you do that. Okay, so let's take a look at the solution. The first thing we need to do is we need to combine the 6 and the 3 ohm resistor. And that is going to give us an equivalent resistance of 2 ohms, which we got from the previous example. That makes this a resistor now in series with the 4 ohm resistor. So we're going to add them together and get 6 ohms. The power supply is 18 volts. If we take 18 divided by the equivalent resistance, which is 6 ohms, that gives us a current of 3 amps. What is the voltage drop across the third resistor, R3? Go ahead and pause the video. Okay, so let's take a look. We know that the current is 3 amps going through the 4 ohm resistor. So we take 3 times 4 and that gives us 12 volts. If you're having difficulty with these, one of the things that I would ask you to do is to, one, make sure that you go through slowly and make sure you work your way through these examples. And keep in mind that these are already here, so I'm going to go rather quickly, but it's really up to you to pause the video and replay if you need to, especially when we're talking about combination circuits. First step when doing a combination circuit is reduce it down to 1 resistor. You cannot add parallel resistors to series resistors. You can only add resistors that are in parallel, or you can add resistors that are in series. You can't do both, okay? So you have to add these 2 first. Once you write the equivalent resistance here, you now have 2 resistors in series. Now you can add them together to get the total equivalent resistance of the circuit. Now once you do that, you can solve for the total current. Once you know the total current, you know that that's the current through this resistor, and it's the current that enters this branch. Once you find the current, though, for this equivalent resistor, you can find the voltage drop on this equivalent resistor. The voltage drop on the equivalent resistor must be the same voltage drop as on the 3 ohm and the 6 ohm. So when you go forward, you reduce it by to 1 resistor. When you go back, you look at the previous circuit. Okay, if I make this 1 resistor, I have 2 resistors in series. What's the same? That's right, the current. So the current would be the same here as it is going in here. Okay, now I go ahead and solve for V1 and V2. It's not going to be 18 volts this time because I have a V3 over here. Okay. I take this current and the equivalent resistor, and I find the voltage drop V on the equivalent. So I find V equivalent. Then that V equivalent must be V1 and V2, and now I can solve for the current. Okay, so let's take a look at the solution. V equals IR is 3 times 4, which is 12 volts. I think we already did this one. Okay, what is the current through the first resistor? Okay, so go ahead and pause. Okay, so let's look at this. There's several ways to do this, and the way I showed you was different than this. Basically, what they're saying is if I take the total voltage and subtract out this voltage, that has to be the voltage on both of these. That gives me 6 volts. And that means that 6 volts is here and 6 volts is here. 6 divided by 3 gives me 2 amps. What is 6 divided by 6 ohms? 6 volts divided by 6 ohms? That's 1 amp. Okay, so I end up with 1 amp plus 2 amps, and that gives me 3 amps. Okay. Which 2 of the following sets of resistors have the same equivalent resistance? Select 2 answers. Okay, so let's see if you have the correct answers. Hopefully you chose A and D. They both have the same resistance. In the next video, we'll talk about measurement.